In this video, we're looking at problem number 7 on page 156. We've got a proof here. We're asked to prove that angle 5 is congruent to angle 6, and we are given that 4 is congruent to 7. So let's take a look at what we've got here. So 4 right here is congruent to 7, and we want to show that 5 is congruent to 6. And I look at this, I see a bunch of vertical angles. So I think this is going to work out pretty easily. So let's go ahead, because if 4 is congruent to 5, they both get single arcs, and 7 to 6, they get single arcs, and everything has a single arc, which means they're all congruent to each other. All right, so here we go. Let's just write out this proof in a more formal way. So here we go. We're going to start off with our given. Angle 4 is congruent to angle 7, and that was given. Then I've got these vertical angles. Angle 4 is congruent to angle 5, and also 6 and 7. So angle 6 is congruent to angle 7, and both of those were from vertical angle theorem, or vertical angles are congruent is what the theorem says. And then let's see. 4 is congruent to 7, 4 is congruent to 5. That means 5 is congruent to 7. That's transitive, because I'm comparing 3 things there. Let me just slow that down. So 4 is congruent to 7, and 4 is congruent to 5. That means 7 and 5 are congruent. And then I look here, 6 is congruent to 7, and 5 is congruent to 7, which means 5 and 6 are congruent, which is what I was going for. And we're done. Transitive property again. Now you might think, why didn't I just do substitution? And technically you can't substitute in a congruent statement. So I had to take each set of 3. So I looked at these right here and said, okay, if they're both congruent to 4, 7 and 5 are congruent to each other. That's how I got this statement there. And then the next thing I looked at was at these ones, and I said, well, if they're both congruent to 7, these have to be congruent to each other. That's how I got that statement.